We're on lesson 4 of chapter 7, which is called Systems of Equations. First, we're going to solve systems of equations by substitution. Then we're going to solve systems by solving for a variable first. Then we'll do a real-world application. So what is a system of equations? Well, that is a pair of equations used in the same situation. For example, we put these two equations onto the same graph. This first equation is y equals 1 times x, or y just equals whatever x is. So if x is 4, y is going to be 4. If x is negative 4, y is negative 4. If x is negative 6, y is negative 6. This equation is y equals 2 times x minus 1. So when x is 2, y is 2 times that minus 1. Anything along these lines is a solution for each equation. The system solution, however, is the set of values that are solutions to both equations. So if you're going to graph it, you're going to find it right at the intersection of the graph at 1, 1 for example. It's a solution to this one because when x is 1, y is 1. It's a solution to this one too because when x is 1, 2 times 1 is 2, minus 1 is 1. So the point that solves both equations is our solution. Sometimes it's at nice whole numbers like this, and other times it's at a decimal or something really more obscure. As you saw here, this system was solved by graphing. You can actually solve systems either by graphing or you can do it algebraically. We're going to be doing the algebraically today. So here we'll be given a system of equations, these two equations here. If you notice on the top here it says solve systems of equations by substitution, and that's what we're going to be doing here. We know that y equals x plus 3. So this equals 1y. Well, I see that there's another y down here, and if they're in the same system, I can plug this in for y because that's the same thing as y. So on the left side here, I'm going to have x plus 3 because that's what this y is. And then on the right side of the equal sign, I'm going to have the 2x plus 5. I know that these equal each other because they both equal y. So if I'm going to solve for x, then I could subtract x from both sides. This will give me 0. This will give me just x. I could subtract 5 from both sides. 3 minus 5 is going to be negative 2. So now I've determined that x equals negative 2. Now that I know what x is, I can solve for y. Since x is negative 2, I can either plug that in here or here to solve for 1y. This one looks easier to me. So y equals negative 2, which is x, plus 3. Negative 2 plus 3 equals 1. So 1 equals y. Usually you write your answer in a coordinate point. So it would be negative 2 for x, 1 for y. So it would be negative 2 and 1. Let's solve that next one then. We have y equals 3x plus 8, and then y equals negative 7 plus 3x. So I see that this is the same thing as y, and here's a y right here, so I'm going to substitute this for the y. So we have 3x plus 8, and that's going to equal negative 7 plus 3x. If you remember last lesson when you have the variable values that match on both sides, that something special happened. Let's see if we can remind ourselves what that is. Let's subtract 3x from both sides. And that gives us 0 plus 8 equaling negative 7 plus 0, or in other words, 8 equaling negative 7. Here you'll notice something. This is a false statement. 8 does not equal negative 7. And if you remember what that means before, that meant that there is no solution. And if you think back to a graph, the solution is where the lines cross. Being no solution, this means that the lines have to be parallel. And if you look, the slope for this is 3x. The slope for this is 3x. They have parallel slopes, which means that they're never going to cross each other, which means there's no solution. Now we need to solve systems by solving for variables first. We're still going to substitute, but we need to figure out what one variable is before we can. We have x minus y equals 3. So to solve for this, I want to isolate that x to find out what that is. So what I can do, if I have x minus y equaling 3, I could add y to both sides. So I now have x equals 3 plus y. So now I know what 1x equals. Now that I know what 1x equals, I should substitute the value for x in for x right here. So my new equation then would be 3 plus y plus 5y equals 39. I see like terms here, plus 5y and plus y. So that's going to give me 6y. So 6y plus 3 equals 39. Subtract 3 from both sides. That makes it 6y equals 36. Divide both sides by 6. Therefore, y equals 6. Now that I know that y is 6, I could plug in the 6 for y, or the equation that I wrote over here. X equals 3 plus y. X equals 3 plus 6. 3 plus 6 equals 9. So x equals 9. If we're going to write that as my coordinate point, this would be 9 and 6. Let's give myself some room here. Now we have 3x plus y equals 8, and then 6x plus 2y equals 39. Let's isolate that y variable first. So we have 3x plus y equals 8. I subtract 3x from both sides. So y equals 8 minus 3x. So now that I know what y equals, I can plug in 8 minus 3x for this y. Let's rewrite this equation. We have 6x plus 2 times this. So let's write this in parentheses. So 2 times 8 minus 3x equals 39. So now we can do distributive property to solve that then. So if we rewrite this, we have 6x plus 2 times 8, which is 16, minus 2 times 3, which is 6x, equals 39. If we're going to simplify this then, we have 6x and then I have minus 6x. 6 minus 6 is going to give me 0, okay? So 0 plus 16, we could subtract 16 from both sides. So 0 is going to equal 39 minus 16, which is 23. And here I see a false statement. 0 is not 23. Remember last time when we had that false statement, there was no solution, which means that these lines must be parallel. So our answer is then no solution. Let's solve a real-world problem then. It says the chart shows the ticket prices for a school play, so $6 for adults and $4 for students. 22 tickets were sold for $108. How many adult tickets were sold? How many student tickets were sold? It gives us two pieces of information here. There's 22 tickets that were sold. $108 were the total sales. So first I can write an equation for the ticket amount. Then I could write an equation for the dollar amount. So let's make A for adult tickets and S for student tickets. So if I said the number of adult tickets, or A, plus the number of student tickets, which would be S, that's going to be a total of 22 tickets. Now if we focus on the money, the number of adult tickets times 6, because there's $6 a piece, so 6 times A, plus the number of student tickets times 4, because there's $4 a piece, so 4S, that's going to equal the $108 that we have. So now to solve this, I can either isolate the A or I can isolate the S. Why don't we isolate the A? So minus S on both sides. So my new equation here would be A equals 22 minus S. So A is 22 minus S. So I could substitute this 22 minus S for this A here. So it would be 6 times 22 minus S plus 4S equals 108. Well, 6 times 22 would be 132. 132 minus 6 times S, which is 6S, We have plus 4s equaling 108. So if we're going to simplify this, I see a negative 6s and a positive 4s. Negative 6 plus 4 is negative 2s. We're going to subtract 132 from both sides. 108 minus 132 would be negative 24. So negative 2s equals negative 24. Divide both sides by negative 2. So s equals positive 12. So that's the number of student tickets that were sold. We could now plug this number of student tickets in for s to find out the adult. That would be 22 minus 12, which would be 10. So the a would be 10. It's asking us how many student tickets were sold. So this would be our answer. It's 12 student tickets sold. To check your work, you could do 12 times 4, which is 48, plus 10 times 6, which is 60. 60 plus 48 equals 108. So this is a correct answer.